Hello mathematicians, puzzlers, and other curious people. In this video, we are investigating an example of a two-variable formula that has to do with squares. And those two variables are going to be the square's side length and area, because that's two important quantities that have to do with squares. So I'm going to use the letter S for the side length and A for the area. Now you'll notice that I used lowercase for the side length and uppercase for the area. That's not unusual because what I'm going to do is set up a formula we could use to calculate the area from the side length. So one thing you might know about rectangles is that the area is always the length times the width. In this case, both the length and the width are whatever that side length is. So the area will be the side length times the side length. Another way we can write that is that the area equals the side length squared, and that is a very useful version of this formula. One thing we might stop and think about at this point is what values make sense for these variables. So certainly we are not going to have negative numbers because anytime you hold a ruler up to something, it's going to measure a positive number. And for the same reason, we're not going to have 0. So S is not less than 0. In other words, S is not negative, and S does not equal 0. So S has to be greater than 0. Now, do only whole numbers make sense? Or could decimals and fractions also work? I think decimals and fractions could also work here because it could definitely be possible for a square to be, say, for example, 1.5 inches on a side. So that could give us a result that could make sense. So I'm not going to say that S needs to be a whole number. I'm going to say that S is greater than 0 and may be a fraction or decimal. So now we can say, okay, these are the values of the side length that make sense. And we can start making a table to see what values of the area could make sense. So one thing I didn't consider is, could there be such a large side length that there couldn't be a square that fits that? Well, no, I don't think so. You could make your side length as long as you want, and then you would be able to draw another side the same length coming off it with the right kind of corner and do that all the way around until you come back to where you start and you've made a square. So we know that the side length could be, for example, 2, and then the area would be, well, let's see, 2 squared, so 2 times 2 is 4. The side length could also be 10 squared, so 10 times 10 is 100. The side length could also be 0.5. 0.5 squared is 0.25. So I'm noticing something about these areas. The area never seems to be a negative number, and that makes sense because it's been squared, and any real number squared is not going to be negative. It's either negative times negative is positive, positive times positive is positive, 0 times 0 is 0. It's never negative. So I see that the area has to be greater than 0. And I do see that if you start with a fraction or decimal, you can get a fraction or decimal as a result. So the area may be a fraction or decimal, just like the side length. We can also sketch out a graph. So I'm sketching my axes. I'm going to put the side as the horizontal axis and the area on the vertical axis. You can think about these also as X and Y if you're used to that. X is your input, Y is your output. Well, in this case, the side length is what we're using as an input and the area is the output. If we have a 1 by 1 square, that'll have area 1. We saw that 2 by 2 squares would have area 4. Let's see, a 1/2 by 1/2 square would have area 0.25. I'm going to use an open circle at the origin because we can never actually get to 0. And it looks something like this. And I'm specifically leaving out anything that would be negative. So that is how you can represent a relationship between two variables in some different ways. By using an equation and the constraints on the variables, by making a table, or by making a graph. And that's really all there is to it, and it can be useful for a lot of different kinds of quantities. Calculator!